Chapter 4 Basic Geometrical Ideas. Page 69. 4.1 Introduction. Geometry has a long and rich history. The term geometry is the English equivalent of the Greek word geometron. Geo means earth and metron means measurement. According to historians, the geometrical ideas shaped up in ancient times, probably due to the need in art, architecture and measurement. These include occasions when the boundaries of cultivated lands had to be marked without giving room for complaints. Construction of magnificent palaces. Temples, lakes, dams and cities, art and architecture propped up these ideas. Even today, geometrical ideas are reflected in all forms of art, measurements, architecture, engineering, cloth designing, etc. You observe and use different objects like boxes, tables, books, the tiffin box you carry to your school for lunch, the ball with which you play, and so on. All such objects have different shapes. The ruler which you use, the pencil with which you write are straight. The pictures of a bangle, the 1 rupee coin, or a ball appear round. Here you will learn some interesting facts that will help you know more about the shapes around you. 4.2 Points. By a sharp tip of the pencil, mark a dot on the paper. Sharper the tip, thinner will be the dot. Here we see 3 different pictures. The first shows the tip of a compass. The second one shows the sharpened end of a pencil. And the third one represents the pointed end of a needle. This almost invisible tiny dot will give you an idea of a point. Page 70. A point determines a location. These are some models for a point. If you mark 3 points on a paper, you would be required to distinguish them. For this, they are denoted by a single capital letter like A, B, C. These points will be read as point A, point B, and point C. Of course, the dots have to be invisibly thin. Try these. 1. With the sharp tip of the pencil, mark 4 points on a paper and name them by the letters A, C, P, H. Try to name these points in different ways. One such way could be this: A, C, P, H. 2. A star in the sky also gives us an idea of a point. Identify at least 5 such situations in your daily life. (4.3) A line segment. Fold a piece of paper and unfold it. Do you see a fold? This gives the idea of a line segment. It has 2 endpoints, A and B. Take a thin thread, hold its 2 ends, and stretch it without a slack. It represents a line segment. The ends held by hands are the endpoints of the line segment. Page 71. The following are some models for a line segment: an edge of a box, a tube light, the edge of a postcard. Try to find more examples for line segments from your surroundings. Mark any 2 points A and B on a sheet of paper. Try to connect A to B by all possible routes. Figure 4.1 shows the same, points A and B, and the different ways to connect them. What is the shortest route from A to B? This shortest join of point A to B, including A and B, shown here is a line segment. It is denoted by AB and an overhead dash or BA with an overhead dash. The points A and B are called the endpoints of the segment. Try these. 1. Name the line segments in the figure 4.2. Is A the endpoint of each line segment? In figure 4.2, we see 2 line segments starting from A. They are AB and AC. 4.4. A line. Imagine that the line segment from A to B, that is AB with an overhead dash, is extended beyond A in one direction and beyond B in the other direction without any end. The figure represents the same. You now get a model for a line. Do you think you can draw a complete picture of a line? No. Why? A line through 2 points A and B is written as AB with an overhead extended arrow bar. It extends indefinitely in both directions, so it contains a countless number of points. Think about this. Two points are enough to fix a line. We say 2 points determine a line. The adjacent diagram, figure 4.3, is that of a line PQ, written as PQ with an overhead extended arrow bar. Sometimes a line is denoted by a letter like L, M. Page 72. 4.5. Intersecting lines. Look at the diagram. Figure 4.4. Two lines L1 and L2 are shown. Both the lines pass through point P. We say L1 and L2 intersect at P. If two lines have one common point, they are called intersecting lines. The following are some models of a pair of intersecting lines. Figure 4.5. We see two adjacent edges of your notebook. We also see the letter X of the English alphabet, and there are the crossing roads. Try to find out some more models for a pair of intersecting lines. Do this. Take a sheet of paper. Make two folds and crease them to represent a pair of intersecting lines and discuss. A. Can two lines intersect in more than one point? B. Can more than two lines intersect in one point? Four 4.6. Parallel lines. Let us look at this table, figure 4.6. The top ABCD is flat. Are you able to make out some points and line segments? Are there intersecting line segments? We have a figure of this table with the top ABCD and the bottom 4 points are E, F, G, H. Yes, AB and BC intersect at the point B. Which line segments intersect at A? At C, at D? Do the lines AD and CD intersect? Page 73. Do the lines AD and BC intersect? You find that on the table's surface there are line segments which will not meet, however far they are extended. AD and BC form one such pair. Can you identify one more such pair of lines which do not meet on the top of the table? Lines like these which do not meet are said to be parallel and are called parallel lines. Think, discuss and write. Where else do you see parallel lines? Try to find 10 examples. If two lines AB and CD are parallel, we write AB two vertical lines CD. If two lines L1 and L2 are parallel, we write L1, two vertical lines, L2. Can you identify parallel lines in the following figures? There are three figures given here. The first one is of a ruler showing the opposite edges of ruler or scale. The second figure represents the crossbars of this window. The third figure shows rail lines. 4.7. Ray. We have three figures here. First one, beam of light from a lighthouse. Second, ray of light from a torch. Third, sun rays. Page 74. The following are some models of a ray. A ray is a portion of a line. It starts at one point, called starting point or initial point, and goes endlessly in a direction. Observe the diagram, figure 4.7 of ray given here. There are 2 points on the ray. They are A, the starting point, B, P, a point on the path of the ray. We denote it by AP with an overhead ray, that is, a line with a single arrow. Think, discuss and write. If PQ is a ray, A. What is its starting point? B. Where does the point Q lie on the ray? C. Can we say that Q is the starting point of this ray? Try these. Figure 4.8. 1. Name the rays given in this picture. 2. Is T a starting point of each of these rays? Figure 4.9. Here is a ray OA. It starts at O and passes through the point A. It also passes through the point B. Can you also name it as OB? Why? OA and OB are same here. Can we write OA as AO? Why or why not? Draw 5 rays and write appropriate names for them. What do the arrows on each of these rays show?